Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of PG Mustard, and this is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hi Michael, I call this topic no backend, but how can we call it else? It's about the idea of stop writing application code in Java, Python, Ruby, PHP, doesn't matter, and using only front end code in your web or mobile app, and also only database side code, and that's it, nothing in between.
Yeah, so we had this is another listener suggestion. So we had a nice question that was all about good practices to build APIs directly in the database, and they specifically mentioned Postgres, understandably.
Right. So I described this topic. First of all, I want to apologize that I'm interrupting you constantly. I cannot promise I will stop doing it, but we had a comment in YouTube, and I agree. I do it quite often. I know this problem. Some people cannot work with me because of it, actually.
So, well, I don't mind, so please don't worry.
But I will try to improve. I will try. So I describe this topic as we 15 or like 20 years ago, it was normal to say that code on client should be very lightweight. It should be some small HTML and so on. In 2004 or so, plus minus a couple of years, things changed with Web 2.0 when Gmail, Google Maps, and other web applications started to write much more code on client side, right? And then iPhone and Android added even more. So I call it, we live in the era of very thick clients, because a lot of code and business logic is coded on the client side, in running in browser or in mobile app. And this already ate some, it took some work from backend developers and changed everything. But then the idea why we still have backend code, if also SQL is quite powerful today, right? We can do a lot. We can extract only the data we need from tables we have. We can work with very efficiently, and actually we can have again stored procedures or functions with a lot of logic on database. So database can be kind of limited application server itself. And also additional thing is JSON appeared, right? JSON is a common format of communication for everyone. This gives us idea why not eliminate the middle of our three-tier architecture, so keeping only client and database. Some maybe some additional middleware, but very lightweight and not needing constant modification in between. Right. So returning to request of our listeners, it was like how to write REST API on top of database easily, or it can be GraphQL server. Yeah. So we want something that will support the development of our applications, client code, and it can be JavaScript, it can be Swift mobile app written in Swift or something else. Right. It's quite natural to think in this direction.
Yeah, I think from a simplicity point of view, it makes a lot of sense. And also a common one I see is a speed of development perspective. If we can write the client and have the database and not have to write something else, that we can get to a version 1 of our application quite a lot quicker.
Also think about data flow here. For example, we have relational database. Of course, relational, what else? Even if it's not relational, data can be stored in JSON. And relational database, I mean, we have very good, strong JSON support in Postgres. For example, we store many parts of our data as JSON, and then data flow. If it's some Python or it's some Java application, we translate this data originally in JSON to some object format, right? Some objects or arrays or some structures, data structures, and then we translate them and give to our client code again in JSON. It feels very strange. This like jumping back and forth. It's called actually data marshalling when we translate too much. So we could take JSON and give JSON, maybe transforming it somehow. Why should we deal with all those objects and arrays? Also, someone the other day, like a week ago, I saw a discussion. There is a book, Bank 4 book about design patterns, object-oriented design patterns.
I don't know it.
Yeah, it's quite old, very popular. It was very popular when I was younger. So it's about various design patterns you should implement in Java, even in PHP we did it, various data mappers and so on, factories, abstract factory, I remember. And now somebody showed the picture of this book and said the least helpful book, you should burn it. And these days, indeed, I think it's not popular at all. And people who invested a lot, like myself, invested a lot of time into writing a lot of code following some object-oriented design patterns, they now regret it because it's good, it's beautiful in terms of some concept, but practical-wise, it's not that good. And working with JSON and things like React, which define how to work with both structure and what to do with this structure in same way. These things changed the world already, and the idea of having very light middleware and allow us to focus only on client code, only on database code, it makes sense, in my opinion. That's why, that's why we have Postgres and others.
Yeah, feels like a good time to dive into Postgres. Do you want to give us a little bit of a top level on what exactly it is and why it's useful?
Yeah, sure. Yeah, first time I saw it maybe like 8 years ago, quite long ago, and I implemented. I used it in several projects, including a case when successfully a small team of 4 Ruby developers were substituted by 10 hours of my work per week with same result. So Postgres is an application written in Haskell, which sits next to your Postgres database. It can sit on other hosts, and of course, it can be scaled. It's stateless, so you can scale it and you can provision more compute nodes. It's like proxy, right? But it allows you to define a structure in database of special format that will define automatically what REST API your client code will be able to use. So, for example, if you have a table, you can quickly define a view in special schema. For example, v1, it's our API version 1. You define as an updatable view, and automatically client code sees endpoint and can read, insert, select from it. And HTTP methods like get, put, post automatically patch are automatically translated to 4 DML statements: select, update, insert, delete. We have so. There is a lot of logic for automation, like play with headers, authentication, and so on and so on. It's already very advanced software, actively developed for many years. Version 10, major version 10 is current. So couple of last years, I'm not following very closely its development, but it's advancing constantly. And this is the project behind, for example, Supabase. Supabase is based on Postgres plus Postgres plus several more components. And so I love this idea. And actually, I already explained why, right? So you can focus. You can say, we have Postgres, and for example, we have one Postgres guy or half of it, like maybe 20% of a Postgres guy per week. We just need to define our tables and these views and so on, and that's it. We whole team can focus on product development, on client code, and go with startup activities, not spending power on API development in the old-fashioned way, right?
Yeah, and it's free to use as well, right? So even if you're not using something like Supabase, it's when I checked it out, it's just plain MIT license, which is awesome. So anybody can very quickly, with a PostgreSDB as a backend, fire this up and have a fully working REST API pretty much immediately, right?
Right. It's also very performant. I remember when I first looked at it, lacked some things like, for example, no offset rule. Offset is a very terrible thing. Most of us know it, but very quick reminder: offset is usually using offset with like limit offset is usually a bad idea, because if you check the execution plan, you will see that all previous entries were fetched and discarded. So instead of it, you should use like how's it called?
Pagination.
Key set pagination.
Key set pagination.
I think. Yeah. And by the way, I've learned from Postgres a lot. For example, this term I learned dealing with Postgres. I also learned about Skitch. I mentioned many times Skitch tool, alternative to Flyway or Liquibase. So the tool to control schema changes and to have schema version control. Also, I also learned from there, just reading documentation and chatting with people in Postgres community, which is also not huge, but very active and good. So you can have very performant API. So it's written in Haskell, very polished. When I joined, they had this offset. So and I don't remember details, but I contributed a little bit to improve how pagination is working and to get rid of suboptimal queries when you have like billions of rows, for example. So right now it's battle proven. I mean, Postgres is battle proven on large databases under heavy load. You can use it. However, there are of course cons. We haven't touched them. In this approach, we have cons. Let's first think if we mentioned all pros. Right.
I think another big pro that people bring up is security. So you can define things in at the database level, and it will inherit those. So it's quite nice to have that in one place, and to be able to trust the data, or to be able to trust Postgres in this specific example, to handle that. So both at the schema level, so which objects are exposed to it, to the Postgres user, and I guess at the row level security policies, which is something I'd never seen used much until I looked into how Supabase were doing things.
Right. Also, so this approach is an alternative to manual implementation of REST API. I think most backend developers did it at some point, and had feeling that there is some repetitive action, like some copy pasting involved and so on. And it's performant and secure, and also it's an alternative. Maybe it also makes sense to think about it as an alternative to ORM, right? Because it's also mapping. But there is no objects here. We're mapping usually either relational data to JSON or JSON in tables to JSON, or a mix of them to JSON. And JSON, of course, is also working with Postgres. I learned about JSON manipulation in Postgres. A lot. Like I was constantly sitting in the JSON part of Postgres documentation because I needed it. And it requires some effort to master JSON skills for Postgres, because there are a lot of operators and functions. But once you achieve it, you like it actually, because it's very powerful and a lot of freedom. You can combine relational data and JSON and give it to your client code so easily. There is we already discussed this stored procedures and database side coding. And many people, we also mentioned that sometimes a few lines in SQL can replace hundreds of lines in Python on Java, right? It can happen easily when we talk about managing data. So we have it here as well, right? In Postgres, this is our approach. We write database side code, and we produce JSON, and we can consume JSON easily. And it gives that's why it gives speed of development actually, right? Because it's so you get rid of all fat, I would say, in coding. You don't need to think about these object design patterns. You just take raw data, do what you need on database side, and give JSON very, very efficiently in development.
Yeah, I guess it's not directly related to this subject, but while we're talking about them, I think I'll include links to a lot of the JSON functions. There's a good list in the Postgres docs it's fun to read, even if you're not planning to use it anytime soon, just to see what is possible. And the other one was, you mentioned the no offset, and I think Marcus Winand deserves a shout out for all of the work he's doing publicizing this movement. But he also, I think, gives out stickers, and he's got a great page on his modern, he's got a great page on his modern SQL website that I'll link to as well.
Modern SQL and use the indexluke.com as well. I like
very good.
It's brilliant websites for those who are interested in relational performance optimization. Also, if a few more words about efficiency of development. If you think about all REST APIs, most of them are repeating some logic, and it's natural to use some declarative form to declare new endpoints and so on, right? So SQL is declarative language, and Postgres can be considered as a declarative way to build REST API, right?
Yeah.
That's why it's so good also. JSON, declarative way, and a lot of things are automated that most of projects need. Enough pros, maybe switch to cons. What do you think?
For sure. And I guess is it worth saying that a lot of these same benefits could be said of similar projects? Like in the GraphQL space, we have things like PostgreSQL, Hasura. It feels, for me, I mean, I might be wrong, but logically it's very similar.
Right. So both open source projects you mentioned, and companies, we mentioned Supabase and you mentioned Hasura. The difference is Postgres is like REST API. There are several attempts to build, it's not my thing, GraphQL, but I know a lot of front-end developers love the idea of GraphQL, especially those who work with React and so on. A nice idea, but it's just, I like experience in this area. There were attempts to build GraphQL ability to create GraphQL APIs on top of Postgres, but also there is Hasura now. Somehow it's also Haskell. They use Haskell as well. What a coincidence, right? And also very successful. So I like to see these successful projects. But it's interesting that I'm not an expert in history, but I know that there are a couple of projects, Parse.com and one more, I forgot the name. One was acquired, Parse was acquired by Facebook, another was acquired by PayPal, and it was more than 10 years ago, or roughly 10 years ago. And the ideas of those companies, which were both acquired and then shut down somehow. The idea was to provide a service and cloud to mobile application developers to avoid the need to fulfill the need in backend development. So, like, These projects were like the class of projects was called, or services was called MBAS, MBAS, mobile MDBAS, mobile database as a service, right? So not database as a service like RDS, but mobile database as a service, meaning that database for mobile app developers, I guess, right? So you have not only database but also some kind of application server equipped with database, and somehow they were closed. I don't know why. Interesting, like, right? So like this, it looks like Supabase and Hasura are a new wave of this idea to simplify backend development for those who want to focus only on front-end development. Right? And they are much more successful and a lot of users, and we see it.
Yeah, and the other big successful one in that space feels like Firebase. I know it's closed source, but it feels worth mentioning that that has been a success. So it seems likely that these other ones could be too.
Right. So Firebase is NoSQL, like key value or document store. On Google Cloud, and it's very successful because, for example, imagine you are mobile app development. You want database, but also if something changes in database, you want your application to receive the change somehow, like automatically, probably using like, I would implement it using like WebSockets, for example, right? So I pushed the change to my application, and this is what Firebase offered. So it's a fully managed database with this synchronization capability, like push the change to client side code, and I think it's still successful, and Supabase is positioned as open source alternative to Firebase. It's based on Postgres plus additional components. I'm not sure how it's implemented in detail, but I guess it's based on maybe on logical decoding and WebSockets. Maybe one day we should invite them to describe it in detail.
Yeah.
Right, but everything is super successful, especially if you're a small team of some startup and you need to quickly change your interfaces and check various ideas very fast, and you don't want to keep whole team of Ruby or Java developers constantly. Yeah, but let's.
How about
Yeah. So sorry, I interrupted you. Sorry.
No, that's my. How about some of the downsides? I guess is what you're going to go on to next.
Yeah. So. Exactly. So
great minds.
If you're a small team, it's good. But what if you're a bigger team? I observe cases when even in bigger companies, things like Postgres or Supabase Hasura also work well. I remember some talk about, I don't remember the company exactly, but it was a big company, and they decided to stop developing their own APIs. It was REST API originally and a lot of development in-house. And they switched, it was one-step switch to GraphQL and Hasura, and they liked it so much, so they talked about it and how to shift it in a big company. So it definitely makes sense for big companies also to consider this approach, definitely. But what are downsides? First of all, like definitely not the main downside is that somehow these middleware components are written in Haskell. If you want to adjust it, well, Haskell is an interesting language, I would say. I tried to contribute there. It was maybe some things I did, but it's definitely you need some mind shift to work with Haskell. And I have huge respect to people who like it and continue using it. So this is probably
all I was going to say is a functional programming language, and for full disclosure, PG Mustard is written in Clojure. So I
full disclosure written in Clojure, right?
Yeah.
Full disclosure written in Clojure. Clojure is also functional language. It's good. Yeah. Like these languages are great, but their adoption is very limited. They are not super popular compared to I don't know, like Go language, for example, or Python. And another problem, like possible downside, is that you will, following this route, you will have a tendency to use more database side code. And if communication with external, it's this problem we discussed this problem in our episode about stored procedures. If you need to communicate with external world, call some REST external API, for example, or to download some binary, for example, a picture, and save it. It's not good to consume CPU cycles on your
primary database,
especially on primary database. Exactly. If it's a function which writes to database, it can be only primary. So you consume CPU, which like very limited resource, the most limited resource in any Postgres cluster. So this can be dangerous. And I remember one day I used even PLSH, which I wouldn't recommend for normal use at all, to save a picture from Postgres. Like I had a call, like they call it, as I remember, maybe still like RPC. So you have like post /RPC / your function name. And this is a function in Postgres, and it was PLSH function, which is like stored function using bash. And then I had some curl calls there and stored. So my Postgres primary node called downloaded image, and then called some additional small microservice it can be S3, for example. You can now save it on S3. It's the approach you never would like to follow unless it's some very rough, quick and dirty prototype of something. It should not be on normal service. Because why? Because CPU on the primary is very limited, and you shouldn't do it at all.
And if you're a new listener, welcome. But also we have a previous episode all about this on stored procedures.
Right. So this is second item in our cons list. What else?
Good question. I've got some cons from developers actually on Reddit. I think the first one, they said that when in one of the places where this was shared, when it first came out, but I didn't check. The top comment on that is, "Thanks, I'm unemployed now." So maybe that's a con. Losing developer jobs, could that be considered a downside?
Well, yes, maybe, but also, to balance it, I saw not once. I saw people who say it's not right to use SQL for it. SQL is okay. SQL is okay language, but I would rather to use my Go or Python or Java for that.
Oh yeah. By the way, I was definitely joking. I think there's plenty of developer jobs to go around, and definitely still more demand than supply. But yeah, I think it's a real.
You're touching
benefit.
a very sensitive topic.
Yeah.
So yeah, but so maybe we could say like a new item on the cons list is lack of libraries, probably, right? Because if you use Python or even Go, or which is newer language, you have so many libraries already written. So you have so huge power to extend your API with additional things. For example, if you want machine learning and you use Django and you decided to this is, by the way, when I replaced Ruby developers in that project. Then later it was fine, but they pivoted this company and they then hired Python developers. One of them is one of my best friends in university. He told me, we are not going to use Postgres anymore. We know Django. We are going to use a lot of machine learning stuff. So we are going to switch from your stuff to Django API development, and we will be using a lot of machine learning. Of course, I could say there is machine learning in Postgres. There is a Madlib, there is Postgres ML, something new, right? So it's possible, and there is PL Python. You can use a lot of Python code inside Postgres. But I failed there. I mean, I not failed. I lost. I lost that battle. Why? I'm not sure, by the way, why. Like, they just said, this is what we use, this is easier for us, more convenient.
I think generally people do have a bit more familiarity with their backend services that they've got used to than they do with Postgres. So one of the downsides is that we are pushing a bit more responsibility and work into the database. So like for example, around those security things, I wonder if that's part of it. Familiarity with how to do that and how to debug things if things go wrong.
No, debugger is a good thing. Yes, IDE and so on. So the same issues as for stored procedures. We covered them in that episode, actually. Yeah, right. But if it's a quite simple API, which doesn't, like, for example, if you have a table, you define a view, as I said. If you just need simple inserts, selects, and so on, and some kind of logic related to which columns should be available for users, everything can be done at view level. You don't need to write a function and use PGSQL at all for this, right? So in this case, probably like it's good, it's enough, and it's faster in terms of development. And actually, people should know SQL in general. But if you need some advanced logic, maybe you'll have issues. Again, it's possible, but yeah. So it depends, and the constant pros are not very strict to me. Like for example, if I take some project, I would reevaluate. Am I going to use Postgres one more time, or I will say, okay, a team of Python developers, you do it. So I have personal preference to use Postgres, of course. And at Postgres AI, we use it for our platform as well, by the way.
Oh, cool. I didn't realize that. Makes sense.
So if we extend something, this is written in React and in Postgres. That's it.
Are there any, this might be a stupid question, but are there any downsides, or is it easy enough to do complex, like maybe quite a complex analytical query? Is that easy enough to do?
Well, any query can be there. So it can be a view, it can be a stored procedure, like RPC.
Oh, but it has to be on the Postgres side rather than...
Right, but
okay.
It should be always on database side. Queries should be there. It's not good to load them like our developers do and do everything in memory. So I don't like this approach. It should be in database.
Makes sense.
Right.
Cool. Anything else you wanted to make sure we covered?
Oh, by the way, I think if, for example, like one more item, it won't be very like strictly defined, but one more item to the cons list. It's more like about Postgres, not about Postgres. Lack of tools for asynchronous nature of work with data. We discussed it also several times. So, for example, you want something, but you don't want to do this heavy work right now. You want to schedule it and then return to processing. And this encourages you to implement some kind of queue inside database, or to use external queuing mechanism. And there are ways to do it, but it like from SQL context, it's slightly more difficult, especially because unfortunately the world of developers lost a very good, in my opinion, tool called PGQ from Skype, developed many years ago. Unfortunately, humanity lost this quite good dinosaur, I would say. I liked it because of performance, its performance, and it was easy to work with. It was good. It had good performance. Some kind of maintenance needed, but much less than for Kafka, for example. And since then, we observe a lot of attempts to reinvent that wheel. Most of them are failing to do it in a way that I would use, that I would be able to use them in large project. So most of attempt to implement queue in database cannot scale well, unfortunately. But this is maybe another topic to discuss. So, and if you use Postgres, you build API, for example, to save picture or some call, I would think about how to have a queue mechanism close to it. What would be your queue mechanism? Asynchronous processing. In this case, you will be fine. Because for most languages, of course, we have libraries to work with, like RabbitMQ, Kafka, anything like that. Yep.
Yeah. Good point. Wonderful. Well, I think that's probably a wrap then. Thank you so much, Nikolai. Thanks everyone for listening, and see you next week.
Yeah, I hope it was helpful. Don't forget to share links and provide new ideas to discuss. Thank you so much. Till next time. Bye-bye.
Yeah. Thank you. Bye bye.